Practice assignment question 5. Week 10. Yes. Okay, so this is the question. Now, can I draw the table of that one? So when x is 0, okay. Clock, if you see that clock is normal clock, so clock is positive edge, okay. X is 0, so when x is 0, what is the output? Q is 0, okay. If Q is 0, that means Z is 1, okay. And when Z is 1, Y is equal to 0, okay. And when clock, again with the positive edge, when X is 1, Q is 1, Z is 0, Y again 0, okay. Mm, given the waveform, yes. So now when X is 0, okay, we consider this particularly positive edge. Okay, we consider only the positive edge. Now at the positive edge when X is 0, okay, so Q is 0, Z is 1, and here 0. So Y is 0. You can see Y is 0. Now when X is this one, again positive X, okay, X is 0, again Y is 0. X is 1, Y is 0, either X is 0 or X is 1. So every case is Y is 0. Okay, so every case is Y is 0. So this is the output. This is the output. the Q waveform. Here Q is the waveform. Clear?
But sir, at the starting the y is 0 and then again it is 1. So why it is?
There is no particular effect of that one, no? Because we are not considering this one. When clock pulse is not applied, we are not considering this particular.
Okay,
So
means it's a don't care type.
yeah. So either there before this one, either the output is zero. Like for example, if I draw this in this way is one, and this one, or either I draw this way, either I draw with some other way. Like I will just draw this one. Okay, then after zero. No issue with that one because we are not considering this condition. Why? Because clock is not applied here. Okay, clock is not applied. Okay, no effect of this one. When the clock is applied, after that we will see the what is the output. Clear?
Yes.
That is only for the confusion. Any other doubts? If we take this one, so t is nothing but x plus q in bar. Okay, t is nothing but x plus q n bar because it is a NOR gate. The logic expression for the next state. Okay, so they are asking the logic state for the qn plus 1. Okay, we are drawing this one for the t. Okay, so can I draw a truth table for here? So x qn plus 1. Okay, x is 0, qn is 0, 0, 1, 1, 0, and 1, 1. Okay, so when x and both are 0, we are getting 1. Okay, and for all other cases, we are getting is 0. Okay, now what is the truth table for t is? When t is 1, output will be the toggle. Okay, so if we apply 0, we are getting 1 as well. Next. And if input is 0, we are getting a same output. So 1. Okay, this is the conditions. Okay, now either we can write for the mean term or we can write for the maximum. So if we write as the mean term, so x bar qn bar plus x bar qn plus x. Okay, take a common x bar plus x qn. That is a x bar plus, so the output is qn plus 1 is nothing but x bar plus q. Okay, if you are taking this one, this is the important question. Okay, this will be asked in some more lots of actual competitive exams. This type of question will be asking about the resistors. Okay, so this is particularly the CPO resistor. CPO. Why it is called CPO? Because the data will be go serially inside. Okay, and you are getting the output with respect to every Q0, Q1, Q2, and Q3. So these are the data. So with parallel data you are getting. Otherwise, you are getting that one data at a time. If it is a CISO, if it is a serial in and serial out, you are getting the one data at a time. But now with every input, you are getting the four datas Q0, Q1, Q2, Q3. So it is called the CPO. Data going inside the serially and data coming outside as a parallel. Okay. Now, if you are taking that clock 0, the data is Q0, Q1, Q2, and Q3. 0, 1, 1, 0. Now, when clock 1 is applied, okay, so in between the clock 0, what will we are getting the 1, 0 XOR. So here we are getting as a 1 because it is XOR. So 1, 0 XORing is 1. Okay, now this 1 will be going inside the Q0. So Q0 is now 1, and all other data will be shifted 0, 1, and 1. In the clock 2, 1, 1 is applied. Okay, 1, 1 is there. XORing of this one, we are getting a 0 here. Okay, now 0 is going at a Q0. Rest data will be shifted. At a clock 3, 1, 0, XORing is 1, so 1 is there, and rest data will be shifted. Now clock 4, 1, 0, XORing is 1, and all data will be shifted 1, 1, 0. Now 1, 1, okay, 1, 1, 1, 0, 1, so 1 is here, and next data will be shifted 1, 1, and 0. Clock 6, XORing of 1, 0 is 1, and remaining data will be shifted. Clock 7, 1, 1 XORing is 0, 0, and next data will be shifted. Clock 8, 1, 1 XORing is 0, so 0, and next data will be shifted. Clock 9, 1, 1 XORing is 0, and next data will be shifted. Clock 10, 1, 0, 1, and next data will be shifted. Clock 11, 0, 0 is 0, and next data will be shifted. Clock 12, 0, 0 data is 0, and remaining data is shifted. Clock 13, 1, 0 is 1, and remaining data is shifted. Clock 14, 1, 0 is 1, and remaining data is shifted. Clock 15, 0, 0 data is 0, and remaining data is shifted. Okay, so now in the question they are asking that the initial content of the CPO is this one. After 3 clock pulses are applied, the element of the shift register. So after 3 clock pulses, what is the data? That means this one, 1010. Okay, 1010. After 7 clock pulse, what is the data? 0111. Okay, 0111. Yeah. Now this question will be like that.
Sir,
Yeah.
actually, I was having a doubt in fourth question. The similar question is asked in the graded assignment week 10 content. It was regarding the CISO people.
Yeah.
And yeah, this fourth question.
Mm-hmm.
But the answer is I know that C and D. Uh, but in the week 10 graded assignment, it is not an MCQ type question. Means same question is this. Same question is repeated in the graded assignment 10, but it is a single choice question. Is this question
Okay,
correct?
you are. Okay, I will check. Yeah, I will check and update if there are possible multiple options, multiple possibilities are there. So I will check that one and update. Okay. Now the question may be like that if we are taking about the Q0, Q1, Q2, Q3, 0, 1, 0, 1. Okay, that is a serial in clock 0. The data is 0, 1, 0, 1. After clock 8, after clock 8, what is the data? After 8 clock, what is the data? Okay, so you can try by one. Okay, so you can try it by one. Okay, so they are taking that one P and N flip flop are there. Okay, that is not a generalized flip flop. P and N. Okay, so one P and N flip flop is there. With respect, we are getting Q and Q bar. The truth table of the P of N is when Pn is 0, 0, 0, 1, 1, 0, and 1, 1. Pn is 0, 0, 0, 1, 1, 0, and 1, 1. We are getting a 0, no change, complement, and 1. 0, no change, complement, and 1. Okay, So if I draw a truth table between the P n and Qn plus 1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so in this situation it is a 0. Okay, 0 1 no change, that means Qn is 0 0 and Qn is 1 1. When it is a 1 0 complement, it becomes a 1 and 0 and 1, both are 1 1, it's a 1. So 1 2 3 4 4. Now can we draw a truth basically equation for Qn plus 1 using the K map? P and Qn 0 0. So P is 0 1 1 1 0 0 1 1 0 and 1. Okay, so one particularly this one and one this one. Okay, one is this one and one is this one. So our equation is the Qn plus 1 is n Qn for this one and for this one plus P Qn. So n Qn plus P Qn plus. So nq plus pqn plus. So this one third option. Okay, the functional table of the circuit given below. Okay, so if I say A, B, Qn and Qn plus 1. So when AB is 0 0, okay, then A is 1, B is 1. Sorry, A is 0, B is 0. Okay, so doesn't mean either the Q is 0 or Q is 1. Always we are getting a 0 0. Okay, and if both are 0 0, we can say that this is 0. If B is 0, we are getting Q is 0. Qn plus 1 is 0. So doesn't mean either Qn is 0 or Qn is 1, no issue. Okay, Qn is 0 and Qn is 1, no issue. It always 0. Now if A is 0, so this is 0, this is 1. AND gate, so any of the input is 0, output is 0. Now it doesn't mean what is the Q, either it is a 0 or it is 1. No, for the B it is issue, it is a problematic. For A, if it is a 0, we are getting a 0 here. Okay, now if Qn is 0, it is 0, so we are getting a 1 here and 1 here. so it is 1. Okay, and when it is 1, D is 1. If it is about 1, Qn is 1. Okay, so when Qn is 0, we are getting a 1. Now if Qn is 1, so here we are getting 1 and this one is 0. So this is already 0, this is also 0. This output is 0. With this D is 0, Qn plus 1 is 0. So when Qn is 1, we are getting 0. Okay, now when A is 1, it is 0. So here we are 0. Okay, now here either we are getting a 1 or 0. When 1, when Qn is 1. Okay, and if Qn is 0, we are 0. So when Qn is 1, we are getting 1. If Qn is 0, we are getting 0. Now if it is a 1, so we are getting a 1 here. If we are 0, we are getting a 0. And finally output is 1 and 0. Okay, so the input that we applied, either Qn is 1, Qn is 0, we are getting 0. If Qn is 1, we are getting a 1. Okay, and finally last both are 1 1. Okay, 1 1. Now it is dependent on Qn. If Qn is 1, so 1 here, we are getting 1 here, we are getting 0 here, 1, and it becomes a 1. If Qn is 0, if it is 0, so 0 here, 0 here, but this one is 1 and this one is 1. So this one is always a 1. This one is always a 1, and if this one is always 1, Q is 1. So either Qn is 0 or Qn is 1, we are always getting, we always get a 1. So can I write down for this too? If I'm considering the equation for A and B as an input, so when A and B is the input, Qn is always 0. Qn plus 1 is always 0. Okay. When A and B is the 0 1, Qn plus 1 is the complement of Qn. Okay. If Qn is 0, we are getting a 1. If it is 1, we are getting a 0. Now these two, we are getting a same. So it is a Q. Okay. And for these two, doesn't mean Qn, we always get it. Okay. So which is the table? The table chat. Now, question number 11. So if you remember the truth table of question number 11, SR flip-flop. So when S and R both are 0 0, 0 1, 1 0, 1 1. Okay, so Qn plus 1, it here it is a Qn, it is a 0, it is a 1, and it is an invalid. It is an invalid condition. Now if you see that in between the S and R, there is a NOT gate is available. So that means if S is 0, R is 1, and if S is 1, R is 0. Okay, so we only consider these two conditions. Don't bother about any other. Okay,
So
because
in short we can put that as a D flip flop. No?
yeah, you can put that one as okay. So here, if you say that this is a D, okay. Now D is nothing but X and Y. Okay, and Y is what? Qn. So D is nothing but X, Qn. So we consider the situation when S, R, and Qn is the input, Qn plus Q. So we can see the S. Only S is important for X. We require only X. X is 0, Qn is 0, and Qn is 1, then X is 1, Qn is 0, and Qn. What we are getting as a S. Okay, so when X is 0 and Qn is 0, S is 0. Okay, so F is 0, that is R is 1. When both are 0, 1, again S is 0, 1. When 1, 0, again S is 0, R is 1. When 1, 1, 1, S is 1, R is 0. Okay, now if S and R both are 0, 0, so we can say it is a 0, 0, 0. And okay, so when X is 1, so first of all check it is a clock first. 1, 2, and 3. Okay, at this point what is Xn? What is X? 1. Okay, and what is Qn? What is Qn? Just previous state. Just previous state. Okay, let's see. One thing is that we are considering this edge. Okay, so what is X at this point is 1, and what is the Qn? We are considering the 1. Okay, we are considering the 1. This previous state here. What is Qn? If Qn is 1, X is 1, Qn is 1, we are getting Y as is 1. Okay, now if we are talking about this state, so what is X? X is 1. Okay, I am just talking about the clock one. This is the clock one. 2 and 3. Okay, clock one when X is 1. But what is the output that is coming if it is considering that this is a 0? So that means Qn is 0. Qn is 0. Okay, If we considering it is a 0, so that means Qn is 0. So if Qn is 0, we are getting here as a 0. From here, we are getting a 0 up to this point. Okay. If x and Qn both are 0, 1, 0, we are getting y as 0. Now clock 2. In the clock 2, what is the value of x? X is again 1. But what is the Qn? Qn, if we are talking about, this is the Qn for that one. So it is 0. So again y is 0. So for this to this one, y is 0. Now again we go to the clock 3, this point. Now x is also 0. Doesn't mean what is the Qn? Qn is either 0 and 1, always y is 0. Always y is 0. So from this point to this one, it is 0. Okay. So equation B is the option. Now we check the option C also. Now we consider that at first clock, x is 1, but we are getting the previous output is also 1. So Qn is also 1. So y is 1. Now second clock, when x is 1, Qn at this point, this output is also 1. So Qn is also 1. So y is again 1. At a third clock pulse, this one, x is 0, but y is 1. Qn is 1. We are getting is 0. But now what we are getting? We are getting a 1. So this option is incorrect. Okay. If we are talking about this one, so at this point, x is 1, but Qn is 0. Why? Because it is coming from the backside. It is 0 on the backside. So y is 0, but you are seeing that it is a 1. It is 1. Not possible. Okay. Now option A, it will be changed in between the clock pulse, so it is also not possible. So which waveform is possible? Only the B waveform is possible. Only the B waveform is possible.
So you were taking the previous state.
Yeah, we have to consider the previous state, na?
Uh,
Like for example, I am just repeating it again. If I am saying that this is my clock 1, okay, this is my clock 1. So at clock 1, what is the value of x? 1. And what is the value of Qn? The previously that is coming. If it is coming 0, so Qn is 0. For A, for B, it is again a 0. Okay. For C, it is a 1. Okay. And D, it is 0. Clear?
yes, sir. And in the second clock, the
Yeah.
can you
Now,
explain the second clock?
yes. I explained this. So this is the second clock. Okay. This is my second clock. Now, what is the value of x?
One.
1. Now, what is the Qn? Previous clock pulse. Okay, at this clock pulse, what is the value of A? So it is 0 for A. Qn is 0 for B. Qn is 1 for C. And Qn is 1 for D. Okay.
Yes.
For the second clock pulse, what is the output? What is the Qn? Qn is the first clock pulse output. Okay.
So why this, sir? The C option is in not
C
match.
option is invalid. Yeah. I just tell that C option is why C option is not right. I just explained the C option only.
Yes, sir.
Clock 1, X is 1 and Qn is 1. So Qn plus 1 is 1. Okay, so till that it is 1. After that it is also. Okay, at clock 2, X is 1 and Qn is 1. Okay, we can say this particularly is the Qn for the next clock. Qn plus 1 is the Qn for next clock. So it is a 1 1, Qn plus 1 is also 1. Okay, now for the third clock, X is what? 0. Qn is second clock pulse, Qn plus 1 is the third clock pulse Qn. Okay, so it is a 1. Now what is the output Qn plus 1? It becomes 0. But you can see the third clock pulse Qn is also 1. If it is a drop here, and it will be go in this pin, then C option is also. Okay, it is a drop here and it will be go 0. It will be the C option is also. Clear?
Yes, sir.
I can take one more timing diagram question is there. Now T is always 1. T is always okay. Now clock is 1. Like we are considering the clock is 1. So when T is 1, Qn, consider Qn is 0. So Qn plus 1 is what? 1. And consider Qn is 1, Qn plus 1 is 0. Okay. If Qn plus 1 is 1, so we are getting y as a 1. And if Qn plus 1 is 0, we are getting y as a 0. Okay. So simply thing is that T is always 1, y is nothing but as the Q and bar. Okay.
Yes, sir.
Now this is the first clock. For this first clock, what is Qn? 0. Okay, sorry. No, not this one. This is the clock. This is the first clock. This is the first clock. So for this first clock, what is the Qn? This one. For A, it is 0. For B, it is a 1. For C, it is a 1. For D, it is a 0. Okay. So what is the output? If it is a 0, we are getting 1. If it is a 1, we are getting 0. If it is a 1, we are getting 0. And if it is a 0, it is we are getting. Clear? So clock 1 is applicable. That means all particularly 4 option is correct for clock 1. Now we go to the clock 2. This is the clock. Okay. When clock is 0, we are getting a 0 output. Okay, when clock is 0, we are getting a 0. Okay, so when clock is 0, here we are getting clock is 0. So we are getting a 0. So in between these two, we are getting a 0. Okay, so D option and A option. B will be not possible, C will be not possible. Okay, yes, any doubt?
Yes. Sir, the expression for y will be clock into q and bar, no? Equation for that.
Yeah, sorry. Y is mm, Q into clock, simply.
So it will be q bar, no? As the t is 1.
If we are taking the Qn plus 1 bar, okay, I am taking the Q only.
Okay.
Okay, Q and D clock both ending, we are getting a Y. Okay, now if I say that this is the Qn plus 1, so Qn plus 1 dot clock. Now Qn plus 1 is what? That is the Qn bar dot clock. Okay, because T is 1, every time the next output will be the toggle of the previous one. So always Qn is the toggle of or invert of the Qn plus 1. So Qn plus 1 is the invert of the Qn. Okay, so either Qn plus 1 dot clock or Qn bar dot clock. Okay, now next second clock pulse. Second clock pulse is applied. Now for the this particularly point, T is what? When T first clock pulse, T is 1. If it is a 0, we are getting a 1. So for A, it is a 1. For B, it is a 0. For C, it is a 0. And for D, it is a. Okay. Now, when the next clock pulse is applied, clock 2. So where A, it becomes a 0. So for this reason, we are getting a 0. So here we are getting 0. Here we are not getting 0. Here we are getting 0. And here we are getting 0. Okay, every data will be inward. So if we are getting a 1, we are getting 0. If we are getting 0, we are getting 1. Okay, here it is 0. So we are getting a 1. Correct. Here it is a 0. We are getting a are getting a 1, but 0 is wrong. And it is a 1, we are getting a 0. Okay. Now for the negative clock pulse, everything will be 0. Everything will be 0. So it is correct, it is wrong, it is wrong, it is correct. Okay. Now the third clock pulse is applied. If we are getting a 0 here, now we have to get a 1 here. Okay, because next clock pulse is applied. In the next clock pulse, it will be toggle. So here we are getting a 0, 1, we are getting a 0, 0, we are getting a 1, 0, we are getting a 1, but we should get 1, but we are not getting. And for 1, we should get 0. Now for the next clock pulse, it becomes 0, becomes 1. It is not correct, so it is a cross. Okay, here we are 1, 0, okay. It is a 1, 0, okay. We are 0, 1, okay. Okay, and for the final negative clock, everything should be 0. So it is a correct, wrong, wrong, and correct. So you can see where all corrects are there. 1, 2, 3, 4, 5. So these are the correct options. Okay. Now any doubts? Yes or no?
Sir, I was having a
Yeah.
doubt in shift register that
Okay.
when you shift the bits,
Mm-hmm.
the previous slide, you have explained that it gets shifted. Means, the question of the practice assignment. Actually, I was having doubt in the grid assignment. It was sixth question. In that means there is a shift register means the bits were Q0 to Q3 and was having value 1101, and the XOR gate was applied to Q0 and Q3,
One
and
one
we
zero one, and this is the Q0, Q3, and XOR gate is applied to Q0 and Q3. Yeah.
and we have to make it 111 means all one.
Yeah.
So how many clock pulses will require? Actually, the
Yeah.
answer I have got it was 10, but in the option it is not showing that option. It is
Uh,
9, 11, 15.
Question number.
Sixth in graded assignment.
This one.
Yeah.
Now what they are saying that initially the value is 1101.
Yes, sir.
Okay. After a certain clock pulse, you are getting a 1111. Okay.
Okay.
Now from that 1111, how many clock pulse you require to get again a 1111?
Means we have to do it twice.
Yeah. And counting will be start from the 1111 to the next 1111. Like for example,
Okay.
initially we are getting a 1101, that is the clock 0. Now for example, now if after 4 clock pulse we are getting a 1111. So from there we start a, that is the clock 0. Okay, actually this is the clock 4, but we are starting from the clock 0 here. Now
Okay.
after that, if you are getting a clock 10 1 1 1 1, so actually you are calculating this one, or you are calculating this one, but we are asking this one from first 1 1 to the second 1 1 1 1, how many clock pulses?
Yes, sir. Got it.
Read the question carefully, it is already mentioned.
No, sir, I was a bit confused. Uh, regarding,
They are mentioned that return to,
uh,
if after a certain clock pulse we are getting the 111, then how many clock pulse it will be take to for the shift register contain to return again 111.
yes, sir. I got confused. Thank you, sir.
Yes.
So if it's not an issue, then I can ask a question related to week 9 assignment, grade assignment. If it
Week 9 deadline is over, na?
means yeah, it's over. But actually, I was facing some problem. The question that
Yes.
which was 11th,
Can you tell me?
11th to 14th. That question.
Okay. The circuit with the enable and output Y is given below. The circuit element has a delay. NAND and the inverter is 40 picosecond. Okay.
So just explain one part, 11th question, and the frequency question that was the 14th question, 11th and 14th.
Okay.
If you were able to explain
Uh,
how to solve these types of questions, because it was
I just tell you one step here.
yeah.
Okay.
Oh yes, sir. Means
Uh, this is
actually
the
the
question.
deadline is over, so you
Yeah, yeah,
can.
that deadline is over. Okay, no problem with that one. But when I T NAND is 100 picosecond and T inverter is 40 picosecond. So you have this is the 100 picosecond. That is the 40 picosecond. Okay. So at t is equal to greater than equal to 0, your enable is 1. Clear? Now we start t is equal to 0. Okay. We are saying that this is the y0, y1 and y2. Okay. So t is equal to 0 second. We are saying y0, y1 and y2. Okay. T is equal to 0. We are saying y0 is invalid, y1 is invalid and y2 is invalid. Till t is equal to 100 nanosecond, y0 is invalid. Okay. I will write something. Question number 5. Yes, any doubt? Till t is equal to 100 picosecond, your y0, y1 and y2, all three outputs are invalid output. Why? Because any changes you have done, that will be appear after 100 picosecond. So you apply the input at t is equal to 0. Okay, you apply the input t is equal to 0. You consider y is equal to 1. Okay, and that particularly will be effective after 100 picosecond. Clear?
Okay.
Okay, so we are taking both case, y is equal to 1 and y is equal to 0. Here it is mentioned in the question. Hmm. Okay, so it is not mentioned what is the y value of y. So we are consider the both values. Okay, so after 100 picosecond, enable is 1 and at t is equal to 0, y is 1. Y is 1 or 0. So what we are getting? If it is a 1, we are getting is 1, and if it is a 0, we also getting. Sorry, if it is a 1, we are getting a 0. Oblique 1. Clear?
Yes, sir.
Now again y1 is the invalid and y2 is invalid. At t is equal to 140 picosecond, it is equal to 140 picosecond, we are getting, if it is a 0, so we are getting a 1 here. If it is a 1, we are getting a 0. Okay, and this one is our invalid. Now t is equal to 180 picosecond. It is 0 oblique 1, 1 oblique 0. Now if it is a 1 oblique 0, we are getting a 0 oblique. Clear?
Yes, sir.
Now again we are saying that y in this case is 1 or y in this case is 0. We say that y2 is invalid at 100 picosecond and that y2 will be the input for the NAND gate. Okay. Now at this point we are getting again y is equal to 1 or y is equal to 0 will be possible. We are getting a same condition here. Okay. After 180 nanosecond, we know that either the y is 0 or y is 1. Clear?
Yes, sir.
So T is equal to 200 picosecond. T is equal to 200 picosecond. So at 200 picosecond, what we are getting? We are getting the response with respect to enable, and the Y2 at T is equal to 100 picosecond. Okay. The output Y we are getting at 100 nanosecond, that will be feedback into the NAND gate, and we are getting the output from the NAND gate after 200 picosecond. Okay, so at 200 picosecond, what we are getting at the output? The enable is 1 and Y is again 1 and 0. So it becomes a 0 and 1. It becomes a 0 and 1. Clear?
Yes, sir.
Again, let's think that we are assume any input that is specific. So assume that Y is equal to 1. That means this becomes 0, this becomes 1, and if this is a 1, 0, 1, 0, and 0. Okay, so let's assume that initially Y2 is 0, Y1 is 1, and Y0 is 0. Okay, T is equal to 0. Now, but this is the invalid. So I just mark as a invalid. Okay, at 100 picosecond, what we are getting? This Y2 will be applied to the enable. So 0 is here, enable is 1, we are getting a 0. So we are getting a 0 here. This is invalid. Okay, after 140 picosecond, with respect to this, we are getting a 1 here, and that is a valid. Okay, and now this is the invalid condition. Again, with respect to this 180 nanosecond picosecond, this 0, 1, and this 0 is the valid. This 0 is valid. Clear? Now, with respect to this NAND gate, after 100 picosecond, we are getting an output of a 200 picosecond. So in 200 picosecond, Y2 is what? This invalid 0. So 0 and enable 1 again is 0. Okay, again a 0. This is 1, 0. Now T is equal to 240 picosecond. With this 0, we are getting a 1, which is, and this is the invalid condition. Okay, and T is equal to 280. We are getting again a 0, valid condition. With respect to 300 picosecond, we are getting a 0, 1, 0. Again, T is equal to 340, 0, 1, and 0, invalid. And T is equal to 380 picosecond, we are getting a 0, 1, 0, valid condition. So after 390 second, we are getting 0, 1, 0. Condition Y2 is 0. Okay, condition is what? Y2 is 0. Okay, so at 350, 350, 350, 350. Yeah, 350. So what is the y2? Y2 is 0. So at 350 y2 is 0. Okay. Now if we say that y2 is 1, if we say y2 is 1, so let's we consume that this is 1. Why I am taking this particularly case? If it is a 1, so here we are getting a 0. If it is a 0, we are getting a 1 here. Now enable is already 1, 1 is we are getting here, so it is a 0. Okay. Now this particularly point and this point is short. So if at this point we are having a 1, how it is possible that we are getting a 0 here? So that means this particularly combination is not possible. The only possible combination is what? That y2 is 0, y1 is 1, y0 is 0, and here we are getting a 0. No, wait a minute, what we have done? If it is a 1, 0, 1, so it is compulsory that there should be 0 is possible. 1, 0, 1. Okay. Initially enable is 0, no? So it is possible that 1 be applied here. At t is equal to t less than 0, it is possible. Okay, so y2, this is the y2 point, y1 point, y0 point, and we consider the y2 is 1. We consider y2 is 1. If it is a 1, here we are getting 0, here we are getting 1. Okay, and t is less than 0, this enable is 0. If it is a 1, so we are getting 1. Okay, now we consider this particular scenario. Now can you check? Can you check? At t is equal to 0, before t is equal to 0, y2 is 1. Now at t is equal to 0, when we apply t is equal to 0, so enable is 1 and this one is the 1. So what we are getting, y0 is 0. But this y0 will be 0 at t is equal to 100 picosecond. Here it is a 0, don't care condition, and here it is a 1, invalid condition. Not don't care, invalid conditions. Okay. After 140 picosecond, what will be happen? Because of this one, it is a 1. This 0 is remain. But this one is the don't care condition. Okay. After 180 picosecond, this is the 0, this is the 1, this is the 0. It is a valid condition. Okay, it is a valid condition. Now, if y2 is changed from 1 to 0, so that will be implement. So how at what time y0 will be changed? If this one is 0, initially it is 1. If it is a 0, enable is 1. This will be changed after what time? If 180 picosecond, y2 is 0, enable is 1, so my y0 is changed, but it will be affected at t is equal to 280 picosecond. Okay, 280 picosecond. So at what is the 280 picosecond output is y0 is 10 and ending is 1. Okay, after 280 picosecond we are getting t is equal to 320 picosecond. At 320 picosecond it is invalid. It is invalid. Okay, so we are getting a 1 here. Now with respect to this one we are getting a 0 here, and this 0 is invalid. Now t is equal to 360 picosecond. This one as it is, this 0 will be as it is. Okay, and because of this one it will be the change. Now it is a valid condition, but they are asking at 350 picosecond. So what is the 350 picosecond? Y2 is 0. Okay, now at 360 picosecond y2 is changed at a 1. Okay, so now we check at a 460 picosecond. Why 460 picosecond? Because NAND gate, due to the NAND gate, the output y0 is changed after a 100 picosecond. After a 100 picosecond. If we consider before the 100 picosecond, we are getting a same output. We are getting a same output. So if y2 is changed at a 350 picosecond, if this particularly y2 point is changed at a 360 picosecond, so this y0 is changed at a 460 picosecond. Any doubt in this one? Okay, now it is 1. Enable is also 1. Okay, so what is the output at 460 picosecond is y0 is 0. Now here no change, no change, and these are the invalid conditions. Now with respect to the 460 we are getting at a 500. This is 0. With respect to this 0 we are getting a 1 here. Okay, and this is as it is. Now t is equal to 540 picosecond. This is a 0. This is a 1, and because of this one we are getting a 0. Okay, now t is 640 picosecond. Why? Because between them y is changed, y2 is changed at a 540 picosecond. So the effect of this y2 will be effective at a y0 after a 100 addition picosecond. After addition 100 picosecond. So 540, the y2 is changed. If y2 is changed by 540, we see the effect on y0 after a 100 picosecond. So 640 picosecond. Now a label is 1. Okay. So 0, 1, it becomes a 1. Now these two condition is invalid now. Now t is equal to 680 picosecond. So 1 as it is. With this one, we are getting a naught, so it becomes a 0, and this is the invalid. T is equal to 720 picosecond. This one, this 0, both are same, and because of this one, we are getting a 1 here. Okay. Now at 720 picosecond, y2 is changed. Enable is also 1. Okay. So after a t is equal to 820 picosecond, this one and this one, this becomes 0. Now these two is the invalid. Okay. Now t is equal to 860 picosecond. The 0 as it is, and because of this 0, we are getting 1 here, and this one is the invalid. Now at t is equal to 900 picosecond. The 0, this one as it is, and because of this one, we are getting this is the invalid conditions. This is the 0. Okay, now enable is 1. If y is changed, y2 is changed 0 and enable is 1, we are getting the effect at 1000 picosecond on a y0. It becomes a 1. Clear? So in this way, we can create a basically timing diagram.
Sir, what did you take the initial value of y?
Y2 I am taking as a 1.
As 1.
Yeah.
Okay.
But sir, in the question it is not mentioned, no, the values are not
Yeah,
mentioned.
it is not mentioned. So how we check that what is the value of y2 is that if we consider t less than 0, so enable is 0. Okay, that means we are getting a 1 here because it is a NAND gate. Either I apply 0 here or either I apply 1 here. Clear? Any doubt?
Okay, sir. Got it. Got
If,
it.
if it is a 1, here we are getting a 0. If it is a
Yeah.
0, we are getting a 1 here. So which we
Yes,
consider,
sir.
either y consider y or 1 or 0. Because if we
1.
consider y is 0, so here we are 0, here we are getting a 1. Okay,
Yes, sir. Understood.
so that's why I'm taking y2 as a
Sir, week 10, question number 6. I have a
week
doubt.
10. Question number 6. Graded or
Yes.
practice assignment?
Graded, graded.
Already explained the.
Sir, I
You
wasn't there.
join
Okay.
later.
I will revisit the lecture.
Okay, you join later, little bit later.
Yes, sir. Yeah. Yes.
Okay. The thing is that in the question number 10, what
I
we
just
are
want to
saying
ask,
that
do I need to dry run that thing, or I can derive a simple expression for this whole shifting thing?
no, you what you have to do, you have to your initial input is this 1101. Okay.
Yeah.
After a
From
certain
there,
clock
I
pulse,
have to like write shift and
after a certain clock pulse, you are getting a 1111.
yes, sir.
Okay. Now you have to consider from the according to the question, you have to consider this is the clock, initial clock or starting of the clock.
Hmm.
Okay.
Hmm.
Now from this one, you have to identify how many clock pulses is required to return or basically regain the same 1111 value.
Yes, sir. But how do we do that? Like, do you have to dry run the thing?
Yeah, you have to basically after every clock pulse, you have to check what is the output.
Yeah,
Q0,
okay, okay. I
Q1, Q2,
thought that
Q3.
there will be some simpler expression for the whole thing. That's why I'm asking.
No. With
Like
every
maybe in
clock
terms
pulse,
of N or Q0,
yeah,
like that.
expression is okay. Expression is okay, but the thing is that better that you can run every clock pulse and
Yes, sir. Okay, got it, sir.
So in that question number 11 that you explained,
Mhm.
uh, means so final value means what will get the final value as the answer is 000. So this,
Where?
uh, the previous question that you explained from the week
Okay,
9, uh,
okay.
uh,
So
the
now
question,
what you have to identify is that you have to check that what is the y at 350 picosecond. Okay, y is what? Y2. So in between 350 picosecond, what is the y2 is 0. Okay. Second timing is what? 550 picosecond. So if we consider the 550, so here, okay, again y2 is 0. Okay, and third timing is what? 650 picosecond. So 640 to 680. Again y2 is 0. So what is the output is 0, 0, and 0.
so means in the starting we can initialize the value by ourselves only,
Yeah,
and then we can move forward.
yes,
Uh,
exactly.
and sir, in that section only, the 14th question related to that only, it was
Mhm.
regarding the frequency.
Okay. Now with respect to this one, can you draw the waveform?
It will be zero only, no, sir, as
Mm,
y to z.
if you are getting a signal here, okay, if you are getting a signal, how many time you are getting the output is 0, sorry, 180 picosecond. Okay. So this is your timing diagram. So 1 divided by 180. What is the frequency? Like for example, what I say is that if we are have a 0, okay, this is your timing. It is any doubt in this particular timing diagram?
No, sir.
Okay, so one waveform is that when it is goes to 0 and then 0 to 1, again it is goes to 0. So this is your one cycle. This is your one cycle. It is 0. Okay, start from the 180 picosecond. It is initially 0 up to 360 picosecond. After that it becomes 1 up to 500 picosecond. Then it becomes a 0. Sorry, 540, not 500, 540. Okay, after it becomes a 0 up to the 720. Okay, then from the 720 to 900 it becomes a 0. Oh, sorry, 1. 720 to 900 it becomes a 1. Okay, so this is your waveform that you draw with respect to the y. Okay,
Okay, sir.
second thing, if you simplify that one, so when you are getting a 0, you are getting a 1 here. After at what time? 100, 40 and 40, that means 180 picosecond you are getting a 1. Now this one is going to the feedback. Okay, 0 1 0. So this is again taking the 180 nanosecond, 180 picosecond. After that it is a 1. So basically it is an, if you see that if this one is a 1, enable is 1, it is a buffer circuit, or sorry, tri-stage. This circuit will be like, if enable is 1, it is this circuit. Okay, if enable is 1, this circuit.
It's just negating the value.
NAND gate, NAND gate with one input fixed as a 1, it behave as a NOT gate. Okay, so it is a simply the circuit is going on. So if we are providing the 0 here, we are getting a 1. If we are getting this one is the 1, we are getting a 0. So if the waveform will be like that, initially sometime it is a 1, we are getting a 0, then 1, then 0, then 1, like this one. Okay, now till what duration it will be become 1? We are getting the output from here to here, it will be approaches, it is a, the output will be remain same, either 1 or 0. Okay, and what time it will be take from approaching from this to this is 180 picosecond. So that particularly duration is 180 picosecond. Now again that particular duration is 180 picosecond. So one waveform, one particularly cycle will be completed into the 360 picosecond. This is the time period. Now what is the frequency? F is nothing but 1 by t. So 1 upon 360 picosecond is around 2 point something. Okay, it is around 2.78.
Okay, got it. Means if this question comes, we have to solve like this one. So it's like it is a bit lengthy.
No
method.
need to use this particularly thing. Okay, no need to use this thing. If this is a 3 odd number of inverters are applied, Okay, so after every particularly inverter output will be the toggle. Okay, so if it is a 1, we are getting a 0. If it we are 0, we are getting a 1. If it is a 1, we are getting a 0. If it is a 0, next state output is the 1. So every particularly next state output will be the toggle of the previous. Okay, so in this way, in this form, a square waveform is created.
Okay,
Okay,
means we have
now,
to observe the that gates, that how they are behaving and their
yeah,
waveform.
yeah. Like for example, if we have, if I'm telling that you that one particularly, this is my circuit. Okay, this is my circuit. Okay, if every particularly will be taking the 40 picosecond. Okay, now we start with the 1. So if it is a initial, or if it is a 1, so here we are getting 1 0 1 0 1 0. So if previous is 1, next is 0. If previous is 0, next is 1. If previous is 1, next is 0. If previous is 0, next is 1. If previous is 1, next is 0. Okay, so this is the waveform. Now if one particular data, one particular level will be approaching here to here, it will be taken 200 picosecond, because 40 40 40 40 45 times. So that means one level will be maintained up to the 200 picosecond. Okay, the next level will be maintained up to the 200 picosecond. So one waveform will be complete in the 400 picosecond duration. Okay, so what is the frequency? 1 divided by 400 picosecond. This is the frequency. Okay.
Yes, sir.
Yeah. So I think with this we wind up today class. Thank
Sir,
you all. Yeah.
Sir, in this kind of circuits, how do we apply potential like 1 or 0? How like 5 volts or whatever logic 1 or logic 0 is
Basically,
needed?
how we apply with this particular circuit, because it is a, if you see, it is a ring counter. Okay, ring circuit. Okay, or basically looping
Yeah,
circuit.
a stable multivibrator.
Yeah, simply. So what we do, we are using, like for example, if we provide the input, so we are using one NAND gate. Okay, where one input we applied and one is the feedback.
No, no, like there are no terminals, right? So
So similarly,
how
what
to
I do now,
produce potential?
I just replace my inverter, one inverter with the NAND gate.
Sir, I can't see your screen.
Oh, sorry. Yes, this thing. Now what should I do? In place of this inverter, I just use the NAND gate.
Okay, 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 got it.
Okay. One input is as a feedback, and one input will be using as an inverter if we apply the input signal.
Okay, okay. Thank you, sir. But sir, then also this also have only one terminal, right? We need two terminals.
Why two terminals? We required only one input now.
Uh, for like we apply potential difference, right?
Okay, potential difference. If you are talking about the potential difference, so what we do here is,
Like we need a source, some kind of battery or AC.
mm, for this one, mm, for the potential difference, how we apply. Uh, Basically, if we are talking about the gates, so potentially if we are using the IC, The potential difference of basically the grounded or DC supply will be applied to the IC positive and grounded terminal. But on the particularly part, we are only using the logic, whether it is a 1 or 0 logic. I think you are familiar with the uh,
Like said, these gates must have some transistors inside them, right?
yes,
So,
exactly, exactly.
so which terminal is for base and which one is collector and emitter?
That is all
Like
dependent on
the
is
5
all
and 0 will be fixed for power, and only
dependent.
one terminal will be available. So, which one is available?
If we are talking about the, like for example, if we are implementation part, so this gates is the combination of the transistors. Okay, so base will be applied, base will be used as a logic. Okay,
Okay, okay, got it.
and emitter and collector will be used as a DC.
VCC and 0.
Yeah.
Okay, sir. Thank you.
Yes, can you get out? Can you get out?
Sir, if possible, in the next lecture, you can take some questions on the timing diagram, that how to draw the timing diagrams.
Okay,
Yes,
no problem.
little bit.
No problem, no problem. Can we can take the timing diagrams
Okay, sir.
question. Okay.
Yes. Thank you, sir.
Hmm.
Have a good day.
Yeah. Thank you all.